Hello everyone, welcome to my channel oneconceptelectrical. This is one of the DC machine question. Let's solve this question. Given it is an DC shunt motor with poles of 10 poles, P equal to 10, and giving an terminal voltage of Vt equal to 30, and running at speed of 120 rpm, and taking an armature current of 1200 amps, and each conductor has an active length of 30 centimeter and armature diameter of 120 centimeter, and given flux density in slot is 0.06 Tesla. Then flux per pole means in the teeth region, it's showing as 80 milliweber. Average force on a conductor, they are asking to find average force on a conductor. If a conductor is housed in slot, the second case is conductor is placed on smooth cylindrical surface. Let's write down what are the parameters they given. They given terminal voltage of 230 and number of poles is 10. They given lap winding. In lap winding, number of parallel paths equal to number of poles and speed of 120 rpm. And they given armature current of 1200 amps. And length of the conductor is 30 centimeter and diameter of 120 centimeter. And given flux density in slot is 0.06 Tesla. We already know the average force on each conductor housed in a slot is B into I into L. B is an average flux density, I is a current through each conductor, L is an effective length. We already know current through each conductor is IA by A. By substituting each one, B equal to 0.06, IA by A 1200 by 10 into L, we get a force of 2.16 Newton meter. 2.16 Newton. First of all, we can able to solve this question in another way. First, we will try to find torque. Torque equal to Zp by 2 pi a into phi into Ia. We already know number of poles equal to number of parallel paths. Then P and A will cancel each other. By transferring Z to other side, we are getting torque per conductor. Then 1 by 2 pi into B into area per pole into current, armature current. By substituting area of the pole is pi into D into L by P. By substituting all this one, we get an torque per conductor. Torque per conductor means Newton meter per conductor is 0.1314. We know force from center of armature is torque by distance from the center. Distance from the center is, this is distance means it will be R, radius. Torque is 0.134, 1314 divided by radius, we will get a Newton force of 2.16 Newton. Similarly, in the second question, they are asking average force on each conductor if conductor is placed on smooth cylindrical surface. Similarly, we know the torque formula Zp by 2 pi a into phi into Ia. Here P equal to A because of lap winding. This and this will cancel each other. By transferring Z to left hand side, we get torque per conductor is 1 by 2 pi into phi into Ia. We already in the phi in this particular data they given of 80 milliweber. They given 80 milliweber. By substituting 80 milliweber here, the current armature current is 1200 amps. We get a torque per conductor is 15.27 Newton meter per conductor. We want to find force from center of the armature. This is radius R. By torque divided by radius means effective distance. We become 15.27 by 16 to 10 power minus 2. Then the force per conductor is 25.45 Newton.